Alright class, today is our types of chemical reaction lab. For this lab you will need a test tube rack with clean test tubes in them. You're going to be doing reaction A, B, C, and D. So these are 4 reactions that will take place in your test tubes. So you'll definitely need 5 test tubes, 4 of which you will label A, B, C, and D with the Sharpies that are located up front. And then you're just going to have an extra one. Make sure that you're ensuring that these are clean. There is nothing in them. You will clean them afterwards. You will also need a test tube holder. You will need a Bunsen burner, of course. I'm going to set this out. You're also going to need, this is a crucible tong, watch glass, your striker to light your Bunsen burner. Please be careful with the flint. And safety goggles will be necessary. So these are all our materials that you will need for the lab today. So first and foremost, make sure that you're getting all of these out. If you're at a station where you only see one Bunsen burner, you will share with the station located across from you. All right, now let's go through the actual lab procedure itself. All right, so 4 reactions are going to be taking place in the actual test tubes themselves. One reaction, reaction E, takes place as you light the Bunsen burner. So the Bunsen burner has propane gas coming through, and in the presence of oxygen with an ignition, so with a flame, it will produce carbon dioxide and water. All right, so for reaction A, you're going to take your test tube labeled A, and you're going to take about 1 ml of calcium chloride solution. So here's your calcium chloride solution. It has certain pipettes that will be next to it, so you're just going to take a ml. It'll be about the width of your pinky finger. You can also look for that on the actual pipette itself. There is a 1 milliliter mark, which is right here. All right, so you're going to add that to a clean test tube. Now, before you go on to the second part, back on the actual date and observations page, you're asked to record the appearance of the reactants before your experiment and the products afterwards. So your reactants for reaction A are calcium chloride solution, and then we have a sodium carbonate solution. So make your observations about them. So once you have your 1 ml of calcium chloride solution, you're going to get 1 ml of sodium carbonate solution. Again, it has a special container and special pipettes. So once you add both of those two together, you're going to record your observations here in the after reaction part. All right, reaction B, you're going to take another clean test tube and you're going to add 2 molar hydrochloric acid. You're going to add about 1 to 2 milliliters. Later on, we're going to learn what that molar part means, especially when we come back from spring break. All right, so add 1 milliliter of hydrochloric acid. So 1 to 2 of hydrochloric acid. It has special pipettes too with it as well. Then you're going to carefully drop a piece of magnesium into the test tube. But before you do that, remember to make your observation. So how does that hydrochloric acid solution look? What does the magnesium ribbon look like too as well? So your magnesium ribbon, I'll have several that are cut out in this container. So the way this reaction will work in B, after you have 1 to 2 ml of your hydrochloric acid solution, and be careful, it can cause burns, you're going to place a piece of magnesium into the test tube. Now this part will be very important. While this reaction is still occurring, what you're going to do is take a clean test tube that's not marked with anything else, and you're going to use a test tube holder and hold it over top like this. So your hydrochloric acid solution is already in here. You dropped your magnesium ribbon in, and then immediately, you can use a test tube holder would be best. So I'll grab one. So you can feel free to hold this one below, and you're going to hold a clean test tube over top. Now when you do this, these need to be vertical. All right, so don't have it tilted like I am. I'm just trying to show you what this would look like. So you're going to hold this right over top of the test tube for 30 seconds. So while one group member is doing this, another group member will take, this is a wood splint. You're going to place this into your Bunsen burner flame, light it on fire. All right, so once that 30 seconds time limit is up, and I'll move this over here to help. So once your 30-second time limit is up, what you're going to do is keep your test tube inverted. You're going to lift it up so you're not tilting it to either one side. You're just lifting it straight up. Then you're going to place that lit, this is a wood splint, right inside. All right, and you are testing for the presence of hydrogen gas. So if you have done this successfully, you will hear a loud pop. All right, so that's reaction B. You may need to try that one once or twice. Aim to only do it once. All right, reaction C. You're going to place 1 small scoop of copper to carbonate. So this is our copper carbonate. Notice before, make observations about how the copper carbonate looks. All right, what do you notice about it? So you're going to place just a small, tiny scoop of this into the clean test tube labeled C. Then what you're going to do, using your test tube holder, these are your test tube holders, you're going to grab it, you're going to place it over the Bunsen burner, and you're going to point the mouth of the actual test tube away from anyone. So make sure you're pointing this in a specific direction. So not only do you want to point it away from yourself, your lab partners, but every other student in the lab classroom. So you're going to hold it right near the flame. And what you're going to do, you're going to remove it from the flame if any of this compound, that copper carbonate, starts to come out. All right, so while one person is sitting here and heating it, another member of the group, you can take that same wood split from before, light the other end of it, and you're going to quickly place it at the mouth of the test tube. And you are testing for the presence of hydrogen gas, and I'll let you see what that looks like. All right, so heat it up, light the wood splint, give it a minute. Don't put it directly in the flame, it's okay, just around it. You're just wanting to heat it, and then you're going to place that lit splint down inside to test for the presence of hydrogen gas. Afterwards, make sure you're recording your observations. All right, D, you're going to take your Bunsen burner that's lit, and you're going to have a watch glass right next to it. You're going to come up front, grab a piece of magnesium ribbon. So this is a different piece than what you used in reaction B. And you're just going to place it down on your actual watch glass. And you're going to record initial observations about your magnesium ribbon. Afterwards, you're going to take, these are crucible tongs. You can pick up the magnesium ribbon too, it's okay. All right, and what I'd like you to do is just secure the end of it. So you don't need to have the whole thing covered with your crucible tongs. Just have it securely enough to where you at least have a piece of it, holding tightly on the end. All right, so now what you're going to do, hold the ribbon in the burner flame until your magnesium starts to burn. This will be important. Do not look directly at the flame. You will see why. It can hurt your eyes. So you're going to hold it right in the flame. Once the ribbon has stopped burning, you're going to place the remains of it in the watch glass. And you're going to examine this product thoroughly and record your observations. So what's the product to look like? All right, at this point, you will go ahead and start to clean your test tubes in your lab station. So rinse everything down the drain with plenty of water, and they're just going to set them out. Maybe even on a a dry paper towel. All right, you're going to put everything back up too as well. So clean your space. I want it to look like you weren't even there. No one was there. And your goggles can be put away as well. All right, so after you've cleaned up, you're going to move on to the data analysis portion of the lab. So each of the 4 reactions we did in A, B, C, and D correlate with one of the types of reactions. E is an extra one, so E has to deal with us lighting the burner, because the burner has propane gas. So what you're going to do is first write and balance each equation. Notice how they are in word formulas. So you, using your knowledge of ionic compounds, you are going to have to write these out, and molecular compounds too as well. So you're going to have to look up what would calcium chloride look like. So you're going to need knowledge of what their initial charges looked like as ions. Make sure you reduce too as well. So once you have this written, you are then going to balance it. So double check with me that you have it written correctly. That way we can have feedback. After you have balanced each one, you've written it, you've balanced each one, then you're going to classify as one of the following types. So composition, another word for that is synthesis. So the correct word is synthesis. Decomposition is where a compound is breaking up. Single replacement is when you have an element in a compound. Double replacement is when you have 2 compounds, and combustion is that special type where you have a hydrocarbon. So you have some type of a compound containing both hydrogen and carbon. Doesn't mean it can't contain other things else like oxygen as well. All right, you have the whole time to do this. Bear in mind, this lab will be due to me by the end of class today. You will also be responsible for your finisher. That is at the end too as well. All right, ask me questions along the way.